Good evening, students. This is the eighth video. Uh, we have to discuss the application of conductancy measurement. Application of conductancy measurement. We also discuss 3 points of a determination of degree of dissociation of weak electrolyte. Then we have discussed 3 points. First point is that first point is temperature. We know that degree of dissociation increases with increase of temperature because dissociation is an endothermic process. So degree of dissociation, that means alpha, increases with increase of temperature because dissociation is endothermic process. That means alpha increases with increase of temperature because dissociation is an endothermic process. For an endothermic process means it will be move forward direction, so alpha value increases. Second point is the dilution. Degree of dissociation increases with increase of dilution. But what is its parameter? Now alpha, which is known as degree of dissociation, is proportional to the square root of volume. That means if the volume increases with square root of volume increases, then the degree of dissociation increases. This is in terms of volume. Then nature of the electrolyte. This is third. We already discussed this one. In case of strong electrolyte, alpha is equal to 100%. In terms of mole fraction, alpha is equal to, in terms of ratio, alpha is equal to 1. In case of weak electrolyte, alpha is less than 100%, or in terms of ratio, alpha is less than 1. So these 3 points we already discussed in the previous video. Today we have to discuss about the fourth one, nature of the solvent. Fourth one, nature of the solvent. देखा जाउछा nature of the solvent. The degree of dissociation depends upon the nature of the solvent. The degree, alpha means degree of dissociation. The degree of dissociation depends upon the nature of the solvent. That means if the dielectric constant of the solvent increases, then the degree of dissociation increases. That means suppose in case of the dielectric constant means the splitting power of a solvent. That means splitting power means the ability of the solvent to split a salt. The ability of a solvent to split a salt is called the dielectric constant. So the dielectric constant, generally written as mu. The dielectric constant of water is 81, highest. then the dielectric constant of DTO heavy water, which you call, is equal to 79. Then the dielectric constant of benzene is organic solvent, very less, 2.5, and dielectric constant of CCl4 is equal to 0. Dielectric constant is a vector quantity. So in case of CCl4, everything is cancelled with each other. That means in CCl4, chlorine, 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 chlorine. If it moves in this direction, it moves in this direction. It moves in this direction, it moves in this direction. So the force acted by this chlorine is cancelled by this. The force acted on this chlorine is cancelled by this chlorine. So CCl4 is 0. As the dielectric constant of water is very high, the degree of dissociation is also high in water as compared to CCl4. As the dielectric constant, of the solvent, as the dielectric constant of the solvent water is very high, then the degree of dissociation, then the degree of dissociation alpha is high in water, as compared to CCl4. When we compare the degree of dissociation of any of the salt in CCl4 and water, the degree of dissociation in water is very high as compared to CCl4. CCl4 has dielectric constant 0, but in case of water it is very high, 81. So the splitting power of water is very high as compared to CCl4. So degree of dissociation in water is very high as compared to CCl4. This is the nature of the solvent. Then nature mixing of ions. We can divide the mixing of ions into two parts. One is common ion effect, another is odd ion effect. There are two types. One is common ion effect, first one is odd ion effect. Then first we go to the common ion effect. When the strong electrolyte having a common ion is mixed with weak electrolyte, then the degree of dissociation of weak electrolyte decreases. What it means? When a strong electrolyte having a common ion with that of the weak electrolyte, suppose you take one of the example CH3 COONA, it is a salt, strong, it is a strong electrolyte. When it mixed with water, it is split into ions, CH3CO minus, Na plus. When this ion is mixed with acetic acid, Acetic acid is a weak electrolyte. Acetic acid is a weak, it is a strong. Acetic acid is a weak electrolyte. CH3CO minus H plus, it is a weak. Then what happens? It is a reversible because it is weak. It is a strong, only irreversible. Forward, it completely dissociate. This is completely dissociate because it is a strong electrolyte. 100% degree of dissociation. Alpha value is 100%. So in this case, acetic acid is a weak, so it is reversible. CH3CO minus H plus. You see, in case of strong electrolyte, this one and this one is common. The strong electrolyte ion, acetate ion, is common with that of the acetic acid. Then what happens? When this is a strong electrolyte, so completely dissociate, so this will go back. Whatever is there, it will go back. So degree of dissociation becomes decreases. Degree of dissociation becomes decreases. That means suppose initial concentration is C is 0, 0. Suppose it forms C alpha, C minus C alpha. If we do not add sodium acetate, then C alpha of acetic acid, C alpha means acetic acid means H plus. The C alpha of acetic acid, that means when we do not add acetate ion, C alpha of H plus ion from acetic acid is greater than the C alpha when we mixed. That means CH3COOH plus CH3COONA with H plus. That means what it means? That means degree of dissociation of acetic acid. That means whatever amount of H plus ion is formed here, if sodium acetate is not mixed and the C alpha is greater than that of the degree of dissociation if acetic acid is mixed with sodium acetate, and whatever H plus ion is formed, it is less than that of acetic acid. That is called common ion effect. That means when strong electrolyte having a common ion is mixed with the weak electrolyte, then the degree of dissociation of weak electrolyte decreases. Then we come to the odd ion effect. Odd ion effect. Odd ion. Next one is odd ion effect. Odd ion effect. In this case also, when the strong electrolyte, when the strong electrolyte having odd ion is mixed with weak electrolyte, when odd ion is mixed with weak electrolyte, then the degree of dissociation, of weak electrolyte increases. In that cases, common ion effect decreases, but in this case increases. When the strong electrolyte having a odd ion is mixed with weak electrolyte, then the degree of dissociation of weak electrolyte increases. What it means? That means suppose we add sodium hydroxide. It is a strong electrolyte. It is completely ionized. It is strong. And suppose we take the same weak electrolyte, acetic acid. As it is weak, it is reversible. CH3CO minus H plus, it is weak electrolyte. then what happens? In that cases there is a common ion, but here there is no ion is common. Here cation different, here cation different, here anion different, here also anion different. So what happens? Now when a strong electrolyte having an odd ion is mixed with the weak electrolyte, the cation anion will react. Whatever it is 100% ionization. With sodium hydroxide 100% ionization, alpha value is 100%, but here alpha value is less than 100%. But when H plus, so sodium hydroxide is added, whatever the OH minus, it combines with H plus. OH minus combines with H plus to form water. So the concentration of the right hand side decreases, because whatever H plus ion is formed, it is consumed by OH minus. So as it is consumed, in the product side the concentration decreases. So according to electrolyte principle, the reaction moves forward direction. More and more CH3CO minus will form, and whatever H plus ion is formed, it was consumed by OH minus. As a result, forward reaction will take place. As the forward reaction takes place, the concentration of acetate ion gradually increases. So degree of dissociation by ionization increases. That means, suppose I tell that, suppose I write once again, CH3COOH, it is reversible, CH3CO minus H plus. Suppose initial concentration C 0 0, suppose dissociation C alpha C minus C alpha, it is consumed by OH minus. So it will not remain in the solution. It is consumed by OH minus of strong electrolyte, which is mixed with H plus ion to form the undissociated water. This is undissociated. It is undissociated water. So all H plus ions are consumed. So but ethic is remains same. That means C alpha of acetate ion in acetic acid. That means C alpha is the concentration of acetate ion in acetic acid. That means when you do not add sodium hydroxide, the acetate ion of the acetic acid is less than the C alpha when of acetate ion of when acetic acid mixed with sodium hydroxide. Because odd ion effect, this plus ion is consumed, so concentration of the product side decreases. So according to the electrolyte principle, the reaction moves forward direction in presence of sodium hydroxide. So more and more acetate ion will form. So degree of ionization increases. So this is called according to the odd ion effect. But how you calculate the degree of dissociation, we already discussed. The degree of dissociation is calculated. The degree of dissociation of weak electrolyte is calculated. Weak electrolyte is calculated as, suppose alpha is the degree of dissociation, lambda C by lambda naught. That means lambda C means equivalent conductance at any concentration. Divided by equivalent conductance at infinite dilution. at infinite NIT, at infinite dilution. That means in case of weak electrolyte, equivalent conductance at infinite dilution can be determined using Coulthard's law. From the Coulthard's law, a law of independent migration of ions are used to calculate the equivalent conductance at infinite dilution. So in this way we can find out degree of dissociation of weak electrolyte. Instead of equivalent conductance, you can also write that molar conductance. If it is given molar conductance, then no problem. In this case also no problem if it is given molar conductance, equivalent conductance or molar conductance. That means if both molar conductance is given to you, just divide molar conductance at any concentration divided by molar conductance at infinite dilution. It is also calculated using the Coulthard's law, a law of independent migration of ion. So this is all about the degree of dissociation of weak electrolyte. Then next to a second one is in the same heading, application of conductancy measurement. Degree of ionization by determination of ionic product of water. Determination of ionic product of water. Determination of ionic product of water. In order to go directly to the ionic product of water, we have some common knowledge like this. A. Nature of the water is neutral. Nature of water is neutral. Here water means distilled water, double distilled water, not drinking water. Drinking water is alkaline. Greater than, if the drinking water pH is greater than 8, on 8 to 8.5, it is the best drinking water. But when you boil this water, pH value is acidic, 6.5. But alkaline water is better than that of acidic water, drinking water. But here water means you thought that it is distilled water or double distilled water. Okay, so nature of water is neutral. That means H plus concentration is equal to OH minus concentration is equal to 10 to the power minus 7 molarity. Temperature is 25 degrees centigrade. If temperature will change, this value also change. Similarly, pH small p plus POH small p is equal to pH is equal to POH is equal to 7. That means in case of water, pH is also equal to 7, POH is also equal to 7. So nature of water is neutral. Second is number of water moles in 1 liter of water. Number of water mole, MOLE, number of water moles in 1 liter water. That means how many number of moles of water is present in 1 liter water. The molecular weight of water is 18. 16 for oxygen, 2 for hydrogen is equal to 18 gram molecular weight. So the number of moles of water is 1 liter. 1 liter means 1000 cc divided by 18. When you divide, it comes 55.5 moles. This much mole of water is present in 1 liter of water. That means when you drink 1 liter of water, this much mole, 55.5 moles of water you drink. Then C. the molar concentration of water, the molar concentration, the molar concentration, the molar concentration of water, that means water concentration is equal to 55.5 mole per liter. This is the concentration of water, 55.5 mole per liter. D. Number of water molecules, number of water molecules, the number of water molecules in 1 liter water. In 1 liter water, we know that 1 liter of water contains 55.5 mole. 1 mole contains Avogadro number of molecules, 55.5 into Na, or 55.5 into 6.023 10 to the power 23 molecules. This much molecules of water is present in 1 liter of water. That means 1 liter of water contains 55.5 moles of water. Concentration A, B, C, D, E. Concentration of H plus and OH minus ions. Concentration of H plus and OH minus ions in 1 liter water. In 1 liter water is equal to कितने ना H plus concentration is equal to OH minus concentration is equal to 10 to the power minus 7 mole per liter when na at 25 degree centigrade. 25 degree centigrade. The concentration of H plus and OH minus ion is 10 to the power minus 7 mole per liter. The number of H plus and OH minus ions, the number of H plus and OH minus ions in 1 liter water. In 1 liter water is number is 10 to the power minus 7 into Na. That means 10 to the power minus 7 into 6.023 10 to the power 23 ions. That means H plus ion is present in 1 liter of water is equal to 10 to the power minus 7 into Na. Na is the Avogadro number. Na is the Avogadro number. Then we will go to the in water. What is the point? A, B, C, D, E, F, G. In water, the number of water molecules, is 2. Number of H plus ions, number of H plus ions. How? The number of water molecules that we know 55.5 into 6.023 10 to the power 23. The number of water molecules. Number of H plus ions is to 10 to the power minus 7 into 6.023 10 to the power 23. Now this is cancel. We get what? 55.5 into 55.5 is to 10 to the power minus 7. Multiply both sides 10 to the power minus plus 7. 55.5 into 10 to the power plus 7 is to 10 to the power minus 7 multiplied by 10 to the power plus 7. In both side you have to multiply. Then what we get? Now 55.5 into 10 to the power 7 is to 1. That means 1 H plus ion is present. 1 H plus ion is present in 55.5 into 10 to the power 7 water molecules. That means 1 H plus ion is present in every 55.5 10 to the power 7 water molecules. That means you see that water is neutral because 1 H plus ion is present etiki number of molecules. Okay, that is why water is neutral. Then GH, what is the degree of ionization of water? Degree of ionization of water. Degree of ionization of water. Degree of ionization means alpha. Water when split it is converted to H plus plus OH minus. Suppose initial concentration is C 0 0. Suppose it dissociates C alpha, it is C alpha, it is C minus C alpha. That means H plus concentration is equal to C alpha. Then alpha is equal to H plus concentration divided by C. Then alpha is equal to H plus concentration is 10 to the power minus 7. C water concentration. Water concentration is 55.5. This much moles of water is present. 55.5 moles of 55.5 moles of water is present. When you divide this, we get 1.8 10 to the power minus 9. That means it is very very weak because alpha value less than 1 is weak, but it is far less than 1. In percentage alpha is equal to 1.8 10 to the power minus 9 into 100. We get 1.8 10 to the power minus 7 in percent scale. In percent scale 1.8 10 to the power minus 7. So water is a very very weak electrolyte. Hence water is a very weak electrolyte. Hence water is a very weak electrolyte. So this is the degree of ionization of water. I will stop here because already half an hour more data will go. It will be difficult to upload. घरे सब रदापि हेले बाहर बुलबनी. तुम्हें जानी तुम गोटे सांग को बाघ नहीं पलैला पाठ पढ़ु नाला बोली टीवी देखुला बोली बाघ ताको धरी पलैला. तापर से पाठ पढ़ा कहू बाघ ताको छाड़ी गला. तुम आउ से छाड़बनी यहाँ फास्ट आउ लास्ट. तेणु तुम कदापि बाहर बुलबनी कि टीवी देखनी. खाली खाता कागज कलम तुम पढ़ न पढ़ले बाघ धरी पलैब आ खाईदेव से आउ से छाड़बनी. तुम कहले से छाड़बनी कारण से बाघ कहीकि जाइए फास्ट आउ लास्ट. तेणु बाहर बिल्कुल बुलबनी कि जमा टीवी देखनी खाली पढ़. कारण प्रति गाँव में 4 5 6 लेखा बाघ छड़ाई. से 2-3 दिन है खाई ना. छेली से खाती खाली मनीष से खाइबे. ତେଣୁ ତୁମେ ଯଦି ନ ପଢ଼ିବ ତୁମକୁ ସେ ଖାଇଦେବ, ଆଉ ସେ ଛାଡ଼ିବନି ଜମା। ତୁମ ସାଙ୍ଗକୁ ସେ ଛାଡ଼ି ଦେଇଛି, କାହିଁକିନା ସେ କହିଲା ଫାଷ୍ଟ ଆଉ ଲାଷ୍ଟ କହିବାରୁ ସେ ଛାଡ଼ିଦେଲା। ତୁମେ ବିଲକୁଲ ଆଉ ଟିଭି ଦେଖିବନି କି ବାହାରେ ବୁଲିବନି, ସଦାବେଳେ ପଢ଼ିବ। ଓକେ, ଆଇ ୱିଲ୍ ଏଣ୍ଡ ହିୟର୍। ଗୁଡ୍ ନାଇଟ୍।